Hi, I'm Dave Perellis, an engineer here at Tektronix. In this XYZs of oscilloscopes video, I'm going to show you how to take voltage and time measurements off the scope display and by using cursors. I'm lucky to be using a brand new TBS 2102 with a function generator, but most of the techniques I'll show you will apply to any oscilloscope. Before I get started, I want to give you some tips on making your measurements as good as possible. Luckily, we covered the controls you'll need in the previous XYZs videos, so if you have any questions, you can watch those. These tips will help whether you're measuring by eye or using the automatic measurements on the scope. To make sure you're taking the best measurements you can, make sure the probe attenuation on the scope is set correctly for the probe you're using. Make sure the signal is triggered correctly so it's stable. Adjust the vertical scale to use as much of the display as you can without clipping the top or bottom. And set the horizontal scale to expand the part of the signal you're interested in. Be careful not to slow down the horizontal scale too much because this can cause undersampling and aliasing. The simplest way to get a quick estimate of time and amplitude measurements is by using the graticule or grid on the scope's display. The graticule is just a type of grid. The TBS 2000 graticule has 15 horizontal divisions. Most scopes have 10. It has 10 vertical divisions. Some scopes have 8. Each major division is broken up into 5 minor divisions. For amplitude measurements, we count the number of vertical divisions occupied by the signal's vertical swing and then multiply by the vertical scale. Let's measure the peak-to-peak voltage of this signal. To make it easier to count the divisions, first shift the waveform using the vertical position knob to line it up on the bottom of one of the grids. Now let's measure the height in divisions. The signal takes up 4 major divisions and 2 minor divisions. Each minor division is worth 0.2 divisions, so the signal is 4.4 divisions from top to bottom. You can see the vertical scale for channel 1 right here. At the moment, it's set to 1 volt per division. This makes the math really easy. The peak-to-peak amplitude of the signal is 4.4 divisions times 1 volt per division, which is 4.4 volts. In a similar way, you can measure time by counting the number of horizontal divisions and then multiplying by the horizontal scale setting. Let's do this to find the period of this signal. One cycle of the waveform takes up 2.5 horizontal divisions. You can see that the horizontal scale is set to 400 microseconds per division. So, the period is 2.5 divisions multiplied by 400 microseconds per division. This equals 1 millisecond. And once you have the period, you can calculate the frequency because it's the inverse of the period. In this case, the math is pretty easy again. A 1 millisecond period translates to a frequency of 1 kilohertz. You can even get a rough idea of the phase difference between two signals with the same frequency. Assuming you were paying attention in class, you can probably see that these two signals are about 45 degrees out of phase. To confirm this with measurements, you'll probably need a calculator. You measure the time difference between the two signals. In this case, the two signals are 40, 80, 120 microseconds apart. You can convert the time into an angle by multiplying it by 360 degrees per the period. In this case, 360 degrees represents a 1 millisecond period, so the conversion factor is 360,000 degrees per second. 120 microseconds times 360,000 degrees per second gives you a phase difference of around 43 degrees. Taking measurements by eye is quick, but it's not very accurate, and as you've seen, it requires doing a little bit of math. On-screen markers called cursors can help you make more accurate time and amplitude measurements. On this scope, you activate the cursors by pressing the cursor button. This scope has 3 types of cursors. time or vertical cursors, amplitude or horizontal cursors, and screen cursors, which is a combination of both horizontal and vertical cursors for time and amplitude measurements. Let's start with time cursors. This is the type you'll probably use most often. Many scopes have cursors, but the exact way you move them will be different between instruments. On this instrument, you move the cursors by turning this multi-purpose knob. The time value associated with individual cursor positions and the difference between them are also shown on the screen. And even though these are called time cursors, they also track the waveform and show you the voltage too. That's why I say these are the most useful cursors. To position the cursor precisely, you use the Fine button. It toggles between the fine and coarse movement of the cursors. Now let's use the cursors to measure the period of the signal. Pressing the multi-purpose knob toggles the selection between cursors. For the period measurement, we'll position the cursors on exactly one cycle of the waveform. The time difference between the cursors then indicates the period of the signal. Time cursors can also be used to calculate the time difference between two channels by aligning the cursors on the zero crossings of the same edge on the two channels. If you want to measure a voltage level or difference, but you don't want to track the waveform, you can use amplitude cursors. Let's measure the peak-to-peak voltage on this signal. I'll position the cursors at the positive and the negative peaks. The individual cursors will give you the maximum and minimum values, and the cursor difference value will give you the peak-to-peak voltage. The third type of cursors, the screen cursors, provide two time and two amplitude cursors that can be individually positioned to obtain time and amplitude measurements. In this video, I showed you how to get a quick estimate of amplitude and time measurements of signals using a scope's graticule. Now you can see how many of your friends even know what a graticule is. I showed you how to take the same measurements using cursors. In the next tutorial in this XYZ series, we'll show you how to use automated measurements to get more accurate time and amplitude measurements with even less work.